Hey, this video is going to be on moles of molecules. So still that same notes packet right there. We're just going to do kind of a little bit of the second page of it. So here's the first part. I tend to do this quite often with you. So for each of the following pair circle, which contains more atoms? Okay, which in other words, remember a mole is 6.02 10 to the 23rd atoms. So which is more moles? More moles, more atoms. So 27 grams of aluminum. So we got to look in the periodic table and see what a mass of aluminum is. Well, we look in the periodic table. And so if you have a periodic table in front of you, which you should have for this video, 27 grams of aluminum is exactly 1 mole of aluminum. This is 1 mole, which means it's 6.02 times 10 to the 23rd atoms. If we look at sodium, sodium is 23 grams for a mole. So 46 grams would be about 2 moles of sodium. So that is more moles. More grams does not always mean more moles, though. Okay, more grams does not always mean more. Look at letter B here. 16 grams of oxygen. Look in the periodic table. 16 grams is exactly 1 mole of oxygen. If you look up iron, 56 grams of iron is also 1 mole. Those are equal. They don't weigh the same, but iron atoms are bigger, so it takes more grams to make a mole. So these would be the same number of moles, same number of atoms. 6.02 times 10 to the 23rd atoms of oxygen, 6.02 times 10 to the 23rd atoms of iron. Those would be equal. Notice here we already have 1 mole of sulfur, so I need to figure out, is that less than a mole, equal to a mole, or more than a mole? Well, for magnesium, 24 grams is 1 mole. So this is a little bit greater than 1 mole. Not by much, but a little bit more than a mole. So this is more than that. And this one, 28 grams of silicon, if you look in the periodic table, is exactly 1 mole of silicon. So that's equal to 1 mole of fluorine in terms of number of atoms. Not in terms of mass, but in terms of atoms. All right. So next question here. Does 1 mole of gold have more mass, less mass, or the same mass as 39 grams of potassium? Well, if you look in the periodic table, a mole of gold is 197 grams of gold. So 997 grams is more mass than 39 grams of potassium. They're both a mole, both the same number of atoms, but gold atoms are way bigger, more massive. All right, let's go to moles of compounds. So now we can have, instead of having moles of individual atoms, we're going to have moles of compounds. So for example, here is a mole of sugar, which contains carbons, hydrogens, and oxygens. So if I have a mole of glucose here, it just means I have 6.02 times 10 to the 23rd molecules. And don't confuse, I know the word moles and molecules, but that's just a coincidence right now. So that is that many molecules. What that means is that compound actually, a mole of that compound actually has 6 moles of carbon atoms, 12 moles of hydrogen atoms, and 6 moles of oxygen atoms that make up 1 mole of molecules, or 6.02 times 10 to the 23rd molecules. A mole of calcium chloride would be 6.02 times 10 to the 23rd molecules of calcium chloride. Now, that mole of calcium chloride actually contains 1 mole of calcium atoms and 2 moles of chlorine atoms. So these are bigger moles. They are more massive moles. All right. So figure out the molar mass or molecular weight of each of the following. So we'll just do a couple of these. So if I want to know what is 1 mole of strontium nitrate weigh in grams? Well, a mole of strontium nitrate would have 1 mole of strontium. It would contain 2 moles of nitrogen because the 2 outside the parentheses. And it would contain 6 moles of oxygen. So that 1 mole of these molecules is actually made up of 9 moles of individual atoms. So to figure out what this would weigh for a mole, we got to add up each one. Well, look at the periodic table. A mole of strontium is 88 grams. A mole of nitrogen is 14 grams, so times 2 would be 28 grams. And a mole of oxygen is 16 grams. Times 6 would be 96 grams. So I have to add all those up to figure out what that would be. And that compound is 212 grams per mole. So that total there 1 mole of strontium nitrate is actually 212 grams. So if I want to get a mole of strontium nitrate molecules, I have to get 212 grams of that compound. Do one more of those. So if I want to get a mole of this compound, I would need 12 moles of carbon, which is 12 grams. So 12 times 12, 144 grams of carbon. Hydrogen is 1 gram per mole on the periodic table, times 22, so I would need 22 grams of hydrogen. And oxygen, I have 11 oxygen atoms, times 16 grams for oxygen on the periodic table. 11 times 16 is 176, I think. Add all those up, and it is 342 grams for 1 mole of those molecules. 342 grams for 1 mole of those molecules. I'm going to skip this one because it's something kind of different that we'll worry about later. All right, so low dimensional analysis with these. I'll do a couple of these problems. So how many grams are in 0.45 moles of H2SO4? So I'm going to start with what they give me. Nothing goes underneath there. Still label has to cancel, so moles there, mole there, so I'm writing the word 1 mole down here. Remember, 2 things a mole is equal to. Avogadro's number of molecules in this case, because we were talking about a molecule, not an individual atom. So Avogadro's number of molecules or grams off the periodic table. Those 2 options. Those are the only 2 options you have to put in there. Well, in this case, it's asking for grams, so we're looking at grams off the periodic table, not using Avogadro's number. And in this case, I have to add up all this stuff. So it's a little bit more difficult than what we were doing before. So hydrogen is 1 gram per mole, and there's 2 of them, so that's 2 grams. Sulfur is 32 grams on the periodic table. And 4 oxygens. Oxygen is 16 times 4. Sorry, I can't see it very well. 16 times 4 is 64. So if I add those 3 up, it is 98 grams of H2SO4 in a mole of H2SO4. So again, just adding the mass up off the periodic table, knowing that there's 2 hydrogens, 1 sulfur, and 4 oxygens. So multiplying 0.45 times 98, you get 44.1 grams of H2SO4 is 0.45 moles. All right. This one is grams to molecules. Going from grams to molecules. So this is not asking you moles. It's not giving you moles, not asking for moles. So we're going to use 2 conversions. Not starting with moles, not finishing with moles, so both conversions. So start with your 7.5 grams of barium nitrate. So grams is here, grams has to go down there. That means I'm writing my 1 mole up here. So remember, grams comes off the periodic table. So we got to add up 1 Ba plus 2 nitrogens plus 6 oxygens. We got to add all those up. So barium is 137 grams in the periodic table. Nitrogen is 14 times 2 of them, so nitrogen is going to be 28 grams. And oxygen, there were 3, but it's doubled outside there, so 6 times 16 is 96 for oxygen. So we got to add those 3 up. I don't know what that is. Hang on. All right, I'm back. That's 261. So adding those up is 261 grams. That is 1 mole of barium nitrate. So a mole of barium nitrate is 261. So 7.5 grams is not even close to a mole. It takes 261 grams to make a mole of that compound. We have way less than that. That label, cancel with that. We don't want to finish with moles, so we want to finish with molecules. Molecules is like atoms, a whole bunch of them. So 1 mole goes on bottom now. My other thing that a mole is equal to is Avogadro's number of molecules in this case, because we are dealing with a compound. A lot of times for molecules, I'll just put MC. So we're going to multiply 7.5 times Avogadro's number divided by 261. A couple decimal places is good. 1.73 times 10 to the 22nd molecules. All right, I'll do one more. 1.25 times 10 to the 22nd molecules of that compound. And 3 wants to know how many moles it is. So since we are finishing with moles, it's going to be a 1-step process. So molecules, need molecules down here. That means I'm writing the word 1 mole up here. 1 mole is how many molecules, not off the periodic table. That's not asking grams. 1 mole is Avogadro's number of molecules. And we're done. This divided by this is less than a mole because it's 10 to the 22nd. And our answer ends up being about 0.02 of a mole. So way less than a mole there. Way less than a mole. Last problem on here, if you look at it, is starting with moles. 0.75 moles. And wants to know mass. We're trying to get to grams. So my 1 mole goes to the bottom, so my labels cancel. And grams goes on top. So for grams this, I have to add up 2 NAs, 1 CR, and 4 oxygens. Do that. So this is 162. Again, that's adding up 2 NAs, 1 CR, and 4 oxygens. It's just asking for grams, so we're done. We're taking 0.75 times that. Don't have to worry about Avogadro's number because it doesn't ask about molecules. And our answer there is about 121.5 grams of that compound. All right, that's kind of quick. Good luck.